Hello, everybody, and welcome to part 11. I think this is part 11. I'm starting to lose track of my FTC programming tutorial videos. In this video, we are going to talk about field-centric mechanism drive using the IMU. So in the last video, when I talked about the IMU, I mentioned two possible use cases for it, one of them being autonomous and the other one being field-centric drive. So field-centric drive is drive mode where the directional control of the robot is in relation to the field, not the robot. So this really only applies to holonomic drivetrains where they have complete freedom of movement, meaning they can slide around in translation without necessarily needing to rotate. And so this way, your robot can be facing whatever direction you want. You can press forward, and it will still move to the other side of the field. You'll press back, it'll still move towards your side of the field, left and right, same thing. Whereas before, you would have to worry about keeping track of which direction on the robot is actually forwards. So if, for instance, you had a strategy where your robot needed to rotate 180 degrees, you would then be driving the robot with reverse controls where its forward is facing at you. Some drivers prefer field-centric drive where they don't actually have to worry about that. They just worry about how the field is, so they never need to think about it. This is something that programmers should talk to their drive team about. If you have a driver that's actually interested in having field-centric drive or trying it, then definitely I would suggest trying this out, but this is something that is very specific to your driver. It's not necessarily better or worse. Some teams prefer this, some teams don't. We're just going to go through setting it up, and I'll leave it up to you to decide whether you want to use it or not. All right, so here we have the mechanism drive with power scaling using the gamepad right trigger that I had set up in a previous example. And all I'm going to do is I'm going to go through and add everything we need in order to turn this into a field-centric setup. So first off, I need to import all of the imports that we need. So if you remember, I need Qualcomm hardware, rev, rotation on robot. I also need hardware IMU, and I also need org first inspires FTC robot core external navigation angle unit. All right, so now that we have all those things, hopefully I spelled them all correctly, we now have everything we need to initialize our IMU. So I'm going to do that now. I'm going to create a new IMU object from the hardware map. Remember that this string here is almost always just going to be IMU unless you go in and change it specifically. Don't mind me just looking at my reference so I actually know what I type. Okay, so now I have to make the new parameters variable, and we need to make a new rev hub orientation on robot. Now, like I said in the last video, this is going to kind of depend on your robot setup, but make sure you get this correctly. I'm just going to do the default configuration, which is just the logos facing up, and the USB is facing forward. Now that I have all of that, I need to make sure that I actually initialize my IMU. So IMU dot with our parameters. Now our IMU has been fully configured. Make sure you double check this piece of code because this will be different for everybody. It's not going to be exactly the same. Everything else you can pretty much copy verbatim. Now that we've done that, we have to do a little bit of math. Now, I'll give a link to a paper that kind of describes what we're doing here in a little bit more detail. I'm just going to give you an example of the math, and you can go ahead and copy it down and implement it yourself. But all it is just some basic trigonometry in order to kind of rotate the inputs, if you will. So we're not going to do anything with the right stick because the right stick is just rotation. We don't need to worry about that at all. All we're going to do is we're going to kind of change the left stick's translational values to be rotated in line with how the field is set up. So the first thing we need to do when we do that is we need to get the heading of the robot. This is going to differ a little bit from what I showed in the last video. So believe it or not, rotating left on the field, I believe is going to be rotating counterclockwise, I believe is actually going to be in the positive direction. Robotics does some weird things with coordinate planes where if you divide up the playing field into a coordinate, forward is actually x, so like up and down would be x, even though you would expect it to be y. So it's not actually the same as what you would kind of expect in mathematics. So I believe that's what's happening here, which is why we have to inverse the output of the yaw that we get from the IMU. I'm not 100% certain on that, so don't quote me, but we have to inverse whatever we get out of this IMU in order for it to actually apply to the math we're going to do. So we need to do get robot yaw pitch roll angles. And like I said before, this is going to return an amalgamation of things that we don't really want. We just want the yaw, and we of course want radians. Now that we have that, we need to do 2 additional calculations before we go and set the power to our motors. We need to change the Ly and Lx variables that we've gotten from our gamepad, and we need to rotate them into their correct space. So I'm just going to call this adjusted Ly and Lx. You don't have to do that, but I'm going to. And in this particular case, we're going to take negative Ly and we're going to multiply it by math.sine of our heading, and we are going to add that to Lx times math.cosine of our heading. We're going to do this a few times, so for adjusted Ly, it's going to be positive Ly times math.cosine of our heading plus Lx times math.sine of our heading. So now that we've done that, believe it or not, that's all the math we have to do in order to rotate our Ly and Lx variables to be in line with the field. There's a few different ways of approaching this. It's not really necessary to understand it. If you want to, go ahead and kind of dive into the mathematics behind it, but I'm not qualified remotely to try and explain that, so I'm not even going to try. I'm just going to do what I know I can do, and I'm going to program. So let's take our adjusted Ly and adjusted Lx variables, plug them into what we already have. Like I said before, we don't need to touch the right stick at all, because if you think about it, the rotation of the robot doesn't change regardless of how it's facing in relation to the field or the robot at all. So anywhere on the field, which direction it's facing, rotating left is still going to be rotating left, and rotating right is still going to be rotating right. Clockwise, counterclockwise, that is never going to change. All right, so I hope this video was helpful. If you find that this math actually does not work out and I've made a horrible, horrible mistake and this is not what you need, and there's mistakes here and it's not working for you, please let me know. I actually don't have a robot to test this on right now, so I'm just kind of writing code, telling you what it does, and hope that it actually does what I'm describing. So if there's any problems, let me know. If I need to change something or re-upload this video, let me know. We're kind of getting into the nitty-gritty of some mathematics here, and it's a little bit sketchy of me to tell you that this is how this is done, even when I don't have a robot that I can actually test it on. So let me know if I've done something wrong or if I can help in any way. Other than that, see you in the next video.